Hey, this is Mrs. Reichelt. In this next video, we're going to go ahead and talk about respiratory volumes as well as capacities. So this video is pretty quick. It doesn't cover a whole lot of information, but there's a lot of definitions and a couple of calculations in here. So we'll go ahead and get started. So normal breathing, you're going to want to write that down. Normal breathing is kind of its own definition. It moves about 500 milliliters of air with each breath. This normal breathing is known as tidal volume. So tidal volume equals 500 milliliters worth of volume, and it's called normal breathing. There are a lot of different factors that are going to affect the respiratory capacity. A couple of them include a person's size. So the larger the person, the larger the tidal capacity that they're going to have. Gender. This means whether a person is female or male. That'll affect the amount of their respiratory capacity. Age, as well as physical condition. So the more fit you are, the higher your capacity for respiratory volumes are, versus if you're not very fit, then you have a lower respiratory capacity. All right, so here's kind of where we're getting into a lot of different definitions. So the inspiratory reserve volume, this sometimes is called the IRV. Basically, this is the amount of air that can be taken in forcibly over the tidal volume. So tidal volume is approximately 500 milliliters, but this would be if you were to take a deep inhaled breath, how much air can you actually get in there? It's usually between 2,100 and 3,200 milliliters. Okay, so your tidal volume is normal. It's in this yellow zone. So basically, if you go past that yellow zone and force air in, about how much can you get? And that's about 3,100 milliliters. So between 21 and 3,200. On the opposite end of that, the expiratory reserve volume, or the ERV, this is the amount of air that you can actually forcibly exhale. So it's basically the opposite of the inspiratory volume. This is if your normal tidal capacity and you try to get rid of all of your air, you're looking at about 1,200 milliliters that you can force out of your lungs. Residual volume. Okay, residual volume is the air that remains in the lung after expiration. So after you exhale, what's left in your lungs? It's basically saying, can you leave all of the oxygen out of your lungs? Well, the answer is no. You're always going to have about 1,200 milliliters that are left over. Okay, so that's basically after your ERV, after you exhale everything out, you still have about 1,200 milliliters remaining. Vital capacity is a formula. So in order to calculate the vital capacity, you're going to take the tidal volume plus the inspiratory reserve volume plus the expiratory reserve volume, and then when you equal those numbers out, it will give you vital capacity. Vital capacity is known as the total amount of exchangeable air. So this includes your IRV, your tidal volume, as well as your ERV. The total amount of your vital capacity is about 4,800 milliliters. Okay. Then dead space volume. Dead space volume is the air that remains in the conducting zone and never reaches the alveoli. That's about 150 milliliters. Then the functional volume. The functional volume is the air that actually reaches the respiratory zone. So even though if you take a big deep breath in, not all of that air that you breathed in is actually going to make it to your alveoli. About 350 milliliters never reaches your alveoli. The respiratory capacities are measured with a spirometer. So this is just a specialized tool that helps you monitor what the amount of the volume of air is in your lungs at any given point. And that looks like it wraps up our video on this. I hope you found it helpful.